Hi, here we are discuss about fast and hardware efficient variable step size adaptive beamformer. This research proposes a novel hardware designs for a variable step size adaptive beamformer integrating the efficiency of both array multipliers and truncated multiplier architecture. The study aims to optimize the design for real-time signal processing applications by evaluating and comparing its performance in terms of area utilizations and power consumptions. The proposed design leverages the advantages of array multipliers for high throughput processing and truncated multipliers for reduced hardware complexity. The results demonstrate a promising balance between a computational efficiency and resource utilizations, making it a compelling solutions for applications with a straightened area and power consumption. Now we can verify the base paper. This base paper is fully designed for the variable step size adaptive beamformer. It's a LMS adaptive filter. Okay, so additionally it will be added with the EVSS concept. Okay, so that is means efficient variable step size. Okay, so here the architecture in figure 3. Okay, so it's showing the 8 input EVSS-RC-pLMS beamformer architectures. So as per this architectures, we have developed this architectures with a Verla HDL coding and synthesized in Vivado FPGA and simulated in modelism software. So here you can check this architecture is having a 4 input linear combiner and 4 input weight update. Okay, so total combinations of this 4 input will construct a 8 input linear combiner and 8 input weight update, and end of the architectures they are added a error computations and the feedback of the error output given again to the 4 input weight update. Okay, and this 4 input linear combiner architectures and 4 input weight update architectures they are given in figure 4 and figure 5, and figure 6 is EVSS unit. Okay, now we can verify the Verla HDL coding part. So this is a Verla HDL coding for array multiplier with a LMS variable step size adaptive beamformer, and this is a top model architecture. So here input signal directly given to the registers. After the register x1 x2 x8, okay, it will be given to the input linear combiner and input weight update model and EVSS unit. Okay, and this simulation result was given here. Okay, desired signal, input signal and error signal. So this is a 5G sequence input. Okay, so if you need a normal sine wave, you can change the input in a test bench. Here you can analyze the sine wave, the input signal and error signal and desired signal. Okay, so both the sequence possible, 5G sequence and a normal sine wave based modulation signal also possible. Okay, and additional coding was designed with a truncated multiplier. So here truncated and array multiplier we are compared. Why? Because array multiplier will take n into n means 2n output, but truncated multiplier will take n output only. This truncated multiplier will reduce the internal and external hardware architectures. Why? Because this truncated multiplier will provide a n output. So using this truncated multiplier we will construct any adders or any memory. That memory also we will map with the 8-bit only. Okay, so here the truncated multiplier given to the adders. Okay, so here example the figure 4 you can verify it. So multiplier output given to the adder. So if we used array multiplier we need 16-bit adder, and we used a truncated multiplier we need a 8-bit adder only. Okay, so truncated multiplier will reduce the internal architecture of this multipliers and also reduce the external architecture of this linear combiner. Okay, the same way the total architecture concept we have reduced it. Okay, and we will analyze the results in Vivado. Okay, so this is a truncated multiplier based signal processing and analysis report, and here you can check. This one is a synthesized summary of array multiplier using LMS adaptive filters with a variable step size. Okay, here LUT will take 3152, but in the truncated multiplier it will take 1902 only. Okay, so as per the truncation multiplier, here we have reduced the number of LUTs in the proposed architectures. Okay, so here you can analyze the proposed implementation and power results. Okay, and RTL schematic of existing array multiplier architecture, and this one is for proposed truncated multiplier and schematic also you have analyzed it. Okay, so here, so this is error computation model, and this one is a EVSS unit, input linear combiner. So EVSS unit means, so this is architecture. Okay, so here we have used a truncated multiplier. Okay, and this one is for RC, ripple carry adder, 8-bit only we have used. Okay, so here this comparisons we have updated in the comparisons table, and the abstract document we have developed. So base paper abstract, improvement of the project, proposed title, proposed abstract, existing system, disadvantages, and the proposed system, related notes for this topic, advantages, and VLSI notes. Finally come with literature survey and references. Okay, thank you.